Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing topics. My name is Scott Williams from the podcast team at Omicron, and I will be your host. A cruise ship is like a floating city with most of the necessities available on land. Of all the conveniences, electrical power is mandatory and a basis for a successful holiday for thousands of passengers. Not only on cruise ships, but also on other ships is electrical power essential. Ships use different types of engines and motors for both propulsion and driving generators that produce electrical power for lighting, various electrical equipment, as well as communication systems on board. The same as on land, these onboard rotating electrical machines are subject to various mechanical, electrical, and environmental forces that can affect their condition. To keep generators and motors reliably operating on the high seas, certain diagnostic tests are recommended on a regular basis. But what are these tests? How and when are they performed on ships, as well as what specific challenges are present in the testing environment and how can they be solved? These are just some of the points that my guests will address in this episode of Energy Talks. With me in this episode is first of all Fabian Oertel. He is an Omicron product manager focused on the diagnostic testing of rotating electrical machines. Fabian was my guest in episode number 2 on the essentials of rotating machine testing. Hi, Fabian. Welcome back to Energy Talks.
Hi, Scott. Hi, everybody. Great to be here again.
Also with me is Patrick Sander. He is an Omicron expert who has many years of field experience with the testing and monitoring of motors and generators. Patrick is also a previous guest in episode number 1 about partial discharge testing versus partial discharge monitoring. Hi, Patrick. It's great to have you back with us.
Hello, Scott. Hi to everybody. Thanks for having me again.
Thank you again for being here. Fabian, I'd like to start with you. How are rotating electrical machines, meaning generators and motors, used on cruise ships?
Well, as you mentioned already in the introduction, cruise ships are like floating cities. So you have to run a lot of services to keep the tourists, to keep the customers happy, and to ensure, of course, an unforgettable journey. And therefore, electrical and mechanical power is needed. And both of them are provided either by motors or generators. The latter one is used to produce electrical energy, which is then consumed by the motor in fans, pumps, compressors, refrigerators, or other small motors down to the mixer to make the cocktails, for example. And additionally, all the auxiliary systems, such as lighting or the communication system, as you mentioned also in the beginning, are also required electrical energy. And this electrical energy, of course, is produced by generators on board. Moreover, the ship propulsion itself is often realized in cruise ships by electrical motors.
Fabian, to clarify, this applies to other types of large ships as well, right?
I would say so, yeah. Maybe there are some small differences, such as the diesel electrical propulsion might not apply to every type of ship, of course. But altogether, the statement applies as well to other ships. In general, I think we can say that the electrical energy consumption on vessels increased over the years. Just imagine the demand of cooling energy on a big container ship, for example.
Are these machines subject to the same or additional operational stresses as generators or motors on land? For example, should their condition be checked more frequently on ships?
Yeah, well, I would say the operational stresses are the same as on land or even higher, maybe, due to the aggressive sea environment. Therefore, I would suggest to check the machines, especially high voltage motors and generators, at least as often as on land.
Fabian, do the types of electrical tests typically used to determine the insulation condition of motors and generators also apply to those on ships?
Yeah, there are not really big differences in particular as on land. As soon as you have a high voltage motor and generator, you have the same or similar insulation system, I would say, as on shore. Therefore, I would suggest the same type of tests than there.
Fabian, could you provide us with an overview of these tests periodically performed on rotating electrical machines on ships?
Of course, an insulation resistance, tangent delta or dissipation factor measurement, PD or partial discharge measurement can be done offline without dismantling the machine. So this gives you already a good idea about the main wall insulation of the motor or the generator. Dismantling the machine is often not possible in this particular environment or only really, really difficult to do so. Therefore, other tests are maybe not always applicable, such as stator core measurements or rotor and bearings tests. Same applies for visual inspection and other mechanical tests too. Nevertheless, by assessing the ground wall insulation with the before mentioned measurements, the condition of the part with the highest electrical stress can be reliably determined.
Can these tests be performed both offline and online? And are there any tests that can only be performed offline?
Good question. Yeah, the insulation resistance and the dissipation factor measurements, for example, can be performed offline only. For a partial discharge measurement, it's a bit different. They can be performed both offline and, if couplers are already installed, online too.
Fabian, when are these tests performed on ships? Are there scheduled maintenance outages during which these tests can be performed?
Well, as the measurements are performed offline, the asset needs to be turned off. And additionally, the terminals should be disconnected to be sure that the asset only is measured and to avoid or minimize external influences. Noise would be a good example during a partial discharge measurement of these external influences. Therefore, such measurements are performed during planned maintenance intervals when the vessel is in the harbor or not the full mechanical or electrical power is demanded by the ship's operation.
Fabian, thank you very much. Patrick, you have recently been performing these offline measurements on generators on cruise ships. Could you tell us about that?
In this particular case, I have supported one of our customers, and this company is a specialist for rotating machines. And for me, it was very great having the opportunity to be part of this interesting and still challenging job. It is important for us here at Omicron to emphasize that we are supporting them. In this case, we regard Omicron as a knowledge and support provider when it comes to diagnostics for motors and generators. But usually, we would not offer these active services as a company.
Was there a reason for performing these tests? Were they requested based on a suspected problem?
I would say there was no special reason for that. Like there was no triggering for the measurements per se. But as already mentioned by Fabian, the PD test combined with classical measurements like power factor, dissipation factor measurements, or insulation resistance measurements give a very good overview about the stator winding insulation and its health. Generally, as Fabian also mentioned, cruise ship operators need to rely on their generators. They are installed on the ships, they need to supply the energy, and with that, the cruise ship operators pay special attention to the safe operation of these generators. So I guess having in mind all these facts that trigger the measurements as an offline measurement in that case.
Patrick, could you describe the measurement challenges in this type of testing environment, such as limited space and noise?
Yes, of course. I mean, you mentioned already two of the main issues that come with the planning of the measurements on the ships. So like the accessibility can be an issue as well as confined space. Generally, these generators are installed on the lowest deck, which typically you would not have an elevator reaching down to that deck. So to face those challenges, you would have to rely on a mobile and lightweight solution, as you might end up carrying your equipment by hand. And of course, it's not uncommon to test those generators while the other generator is running on load or even full load to the generator that you're testing. So in that case, you are measuring in a very noisy environment. And in this case, I would say you have to really rely on your colleague doing the test with you, because the communication might be very limited while doing these tests because of noise.
What have you found to be the best ways to overcome these measurement challenges? For example, types of testing devices used.
So unfortunately, for the noise, like for the noisy diesel motor that's running on full load next to your generator you're testing, there's not much you can do. So you have to live with that. So as said, you really have to rely on your partner at site. So the tool talk before making the measurements, the planning of the measurements, and like going step by step through the measurement is very important. Fortunately for the other topic, when using the Omicron test equipment that we have, in this case, we were using the TD15 test set with the CPC 100, is a very lightweight solution. So in this special system, we have a very convenient connection system or connection principle. And what I should mention in that case is that normally when you are testing generators on site, you need to have your power or your voltage that you apply to the generators coming from a regular socket from the wall. So you need to ramp up the voltage. And for that, you have some capacitive current that you have to supply somehow. So since you're not getting all the energy from your socket, you have to compensate that. And in that case, we're using compensation reactors. And basically, you can imagine that as it's copper windings in a housing. So even though they are pretty lightweight for the solution, we're still talking about some 40 kilos or something. So imagine carrying them down a steep ladder is not your favorite option. So with that, the connection principle that I just mentioned comes back into play. With this, we are able to only install a limited amount of equipment downstairs at the generator, so on the lowest deck. In that case, our sensor, which is a PD coupling capacitor, and our MPD 800 acquisition unit, which is installed to the motor, to the generator itself. But the voltage source, so the TD15, can stay one deck above. So in that case, normally that would be a deck where you have an elevator reaching that deck. So in this case, we were really lucky and was super convenient with the connection principle and the connection setup. And we were really kind of addressing the problems that we might face on a cruise ship.
Patrick, could you describe some of the offline tests you performed and how they were set up?
So basically, we conducted all the tests that Fabian mentioned before. And usually when I do those tests, I start with a pretty standard measurement, which is the insulation and the polarization index measurement. Then if I have the chance and I can open the star point, I would check the windings ohmic resistance. And then basically after doing that, I would start with the wiring of the high voltage measurement. So in that case, I would perform the 10 delta or power factor measurement. And then I would set up everything for the PD measurement. So in that case, installing the coupling capacitors, wiring everything. And I want to use this PD measurement, this offline PD measurement, as an in-depth analysis of the insulation system.
What is important to check, and how long did you need to perform all of these tests?
So first of all, we're talking about high voltage measurements, right? So in our case, we're talking about a voltage source up to 15 kV of applied voltage. So in this case, the first and to me most important topic, of course, is safety. Before all tests can be wired, the generator must be switched off and must be isolated. After doing that, we can open the cubicles and we can start the inspection as such. And then we would verify that the machine is really voltage free. So that would be the most important and the first step we're going to do. Switch off the generator and test whether it's really voltage free. And then typically we would disconnect everything from the windings termination and connect the voltage source and the PD coupling capacitor as close as possible to the termination itself. In that regard, I mean, without having any instrument transformer like a CT or like a VT in between, blocking any signals or interfering with any signals. The test itself, so when we're talking about the PD test itself, only takes some minutes per phase. However, combining it with the mentioned measurements as before, with the insulation resistance measurement and the polarization index measurement, which alone takes 10 minutes per phase, in total, it takes like roughly 2 to 3 hours for testing everything on that generator. And with that, I mean 2 to 3 hours from really switching off the generator and putting it back to the grid, like synchronizing it back to the ship's grid.
Patrick, were you able to detect any problems? And if so, how was this presented in the measurement data?
I would say this depends on how one would characterize problems associated with PD and rotating machines. Naturally, electrical motors and generators have partial discharge activity. This relates back to the tape insulation and generally the way the insulation system is built up. Fortunately, in our case, or in all the cases for motors and generators, we're using mica, which is a PD resistive material, and that doesn't cause any severe risk to the safe operation. And in the case of the testing on that chip, we only found normal PD activity, which was fortunate for the customer and for the safe operation. However, there are, of course, defects like PD activity in the slot, which we call slot discharges, that might be of concern.
What are the actions that need to be taken when a problem or developing problems is detected?
In case defects like slot discharges are detected, we need to analyze them carefully. With that, I mean that further measurements either on or offline should be conducted to check any potential change over time. We can also combine visual inspection. As Fabian mentioned, we have limited option to do that, but for example, using endoscopy instruments, we could really try to check the internal assembly of the machine. And usually this might be quite difficult, but doable using the endoscopy. So the thing is, normally we wouldn't be able to disassemble the generator on site, so we have limited option to check it. But also what I mentioned, we should redo the test. I mean, we're doing a test today and we find something and we want to verify this, whether it's changing over time, whether it's also happening online. So we need to find different measurements and different methods to combine the results from those measurements we did today with the results from the future to see and verify whether something is changing to the worse in the future.
Patrick, how could online partial discharge monitoring be applied to the condition assessment of rotating electrical machines on ships?
First of all, one would need to install PD coupling capacitor into the machine. Then both temporary or even continuous online measurements or monitoring would be possible. And with that, the operator would get a very good overview of the assets over time and verify potential defects that have been detected with an offline measurement. And with that, we are also able to analyze them if they are also happening under normal operation.
So how can online partial discharge monitoring work in conjunction with offline partial discharge testing on ships?
The online measurements, either done on a schedule basis, say every 3 months, or done continuously with a permanent monitoring system, would give an additional overview of the condition of the generator over time, and most important, under real load and live operation. Typically, offline measurements are quite sensitive to detect weak spots in the installation system. However, online measurements complement offline measurements. And having said that, offline and online measurements should always be combined. One should not choose either offline or online, but combine the advantages of both to get the best results.
Thank you, Patrick. Fabian, coming back to you, Patrick described some of the measurement challenges of performing offline testing on rotating machines in the confined spaces of ships. Could you tell us which other testing environments also present these challenges where the same test setups used on ships could be applied?
Good question. Straight away, I would say, especially in the industrial environments, we see many cases where especially high voltage motors are installed in narrow space. In this case, it's very useful to have devices which, as you can imagine, fit easily in an elevator or in general are portable. But also other reasons are proving the benefit of a modular portable system. Just imagine the transportation in a normal car without any special truck driver licenses, or where you can drive much faster on the highway, for example. And finally, also for shipping the devices via airplane or container, it's much easier if they are compact and modular. And due to their modularity, you do not need to always ship the entire system, for example. So some CRs, for example, CR600s, can be left potentially at home depending on the capacitance of the test object.
So in this context, could you explain the benefits of multifunctional testing using a limited number of testing devices?
Well, as explained before, especially logistic in general, as well as the accessibility on site, is for sure a topic. Additionally, I would say all the reporting can be done in a single software, and the user does not need to deal with different devices and operating systems. So although they are usually designed for an easy use, all of them do have their particularities.
Patrick, can you confirm this with your field experience?
Absolutely. I was working in my previous job for a service company for a rotating machine, and we really tried to limit the number of devices, of not just devices as such, but also of different vendors to a minimum. We have to face the fact that when talking about PD and partial discharge measurements, we're talking about expert measurements, expert equipment, and expert software. And you would not want to have many different devices in your pool that come with intensive training, maintenance efforts, and introductions to the test device. So you really want to limit the number of devices you use for the testing in field.
Now I have a question for both of you. In general, what do you both see as future trends for rotating machine testing and monitoring? Fabian, what do you think?
From my point of view, and we saw this many times in practice, that the online monitoring cannot replace the offline measurement. As Patrick already said, this is something which is complementary. It has various reasons. One, of course, is that some measurements are simply not possible to be performed online. Another is that some measurements, like the partial discharge measurement, are enabling more diagnostic insights than the other ones. Nevertheless, as Patrick also mentioned, also the online measurements have their benefits, which means that, as I said already, or as Patrick pointed out already, that both measurements are complementing each other. What is also true, I would say, is that the downtimes for the machines are becoming shorter and shorter, and the time pressure for service teams or service provider is very high. Therefore, I think with a multifunctional device using an intuitive connection concept is allowing the user to build up everything within a short time, and we are moving in the right direction with our systems there. Additionally, of course, a user-friendly guidance through the measurement keeps the human errors as low as possible and avoids necessity of repeating the measurement. Finally, a one button or fast reporting, which is possible in our primary test manager, combines all the measurements, including the PD data, and reduces, of course, the processing time, the post-processing time, to a minimum.
Patrick, what is your opinion?
I think in general, there's a trend in the industry to limit downtimes, as Fabian just mentioned, and reduce outages as much as possible. With that, certainly online monitoring or the demand for it has grown over time, but that does not mean installing monitoring system on all assets would simply be the solution to everything. I would say we previously had a phase where asset owners thought when investing into online monitoring, they would save lots of time and money because not performing offline measurements anymore. And now I think the general understanding for it has grown, and people combine the advantages, as mentioned before, of both methods and get the best outcome for them. So there's always a combination. I think people have accepted that, and people are trying to get the optimum from both measurements and, for example, do an offline measurement every 3 years or once a year, while still having a monitoring system that monitors everything under real condition, and combine the results from both measurement methodologies and get really an in-depth analysis of their asset.
Fabian, where can our listeners get more information about rotating machine testing and monitoring at Omicron?
Thanks for that question, Scott. That's an easy one. Just visit our homepage or contact us directly. But also our contact details can be found on our homepage, of course. So just take a laptop, tablet, smartphone, or any other device and type omicronenergy.com in your browser and enjoy reading.
Patrick, are there any training courses or webinars offered by Omicron Academy that may be of interest to our listeners on this subject?
I would say yes, and it's also very simple getting the details for that. So we are regularly hosting and uploading webinars addressing partial discharge topics like online monitoring or offline testing. And you can find the available courses on our website. That's www.omicronenergy.com. And there's a segment called training. But we also host events with a focus on partial discharge, like our partial discharge symposium that is upcoming in March for the region of South Asia. And you can find those dates under the events section on our websites. Last but not least, you can always reach out to your local Omicron sales partner to request an individual training or webinar. The contact details of them can be also found on our website.
Fabian and Patrick, thank you very much for joining me for this episode of Energy Talks.
Thanks to you, Scott. It has been a pleasure as always, and I'm looking already forward to the next episode. Thank you.
Also from my side, Scott, thank you for having us today. Again, it was a pleasure being here, and I hope we have some interesting discussions in the future. Thank you.
And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, including the testing and monitoring of rotating electrical machines. And of course, it offers you the matching solution for your application. For more information, be sure to visit our website at omicronenergy.com. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.